Dear students, now we will look into the last concept in this module number 4, energy methods and energy principles, that is analysis of truss using unit load method. So the procedure goes very simple. First you analyze the given truss for the given load by using either method of joints or method of section. Then you analyze the same truss for a unit load at the point where you want to find the deflection, and again you analyze the truss using either method of joints or method of sections. Now finally you find the deflection using a formula summation pKl divided by AE, where A is the cross sectional area, E is the Young's modulus, L is the length of the member, K is the member force due to a unit load, and P is the member force due to the applied load. Now let us consider a problem. Find the vertical deflection at joint C for the truss shown in following figure using unit load method. Take E equal to 200 kilonewton per millimeter square, or 200 into 10 raised to 3 Newton per millimeter square. This is a truss. Same truss we have solved by using Castigliano's theorem, and also there is a video for the total strain energy method for the same problem by Rakesh Borkar sir. Now let us see how to solve this particular problem. So first of all, for the same problem you analyze by using the method of joints or method of section for the given load. So the given load is 40 kilonewton. The same truss you consider and analyze it either by using method of joints or method of sections. You get the member forces. List out all those member forces. So we have solved this particular problem in total strain energy method and also Castigliano's method. So those results we will take as the input, and we have listed out the member forces. FCD equal to minus 89.43 kilonewton, FCB equal to 80 kilonewton, FBA equal to 80 kilonewton, FDE equal to minus 89.43 kilonewton, FEA equal to 40 kilonewton, and there are two nil member forces. They are FDB and FAD equal to 0. Now in the second step, replace that applied 40 kilonewton load by a unit load at the point where you want to find the deflection. Here I want to find the deflection at point C, so I will apply a unit load at point C and I will remove the applied load 40 kilonewton. Instead of 40, you apply 1 kilonewton and analyze the entire truss by using either method of sections or method of joints and find out all the member forces. Now in the same way, let us consider the joint C. This is a joint C. The free body diagram of joint C is shown here. The angle theta is equal to 26.57, tan inverse of 1.5 by 3, tan inverse of 1.5, this is 1.5 divided by 3, works out to be 26.57, you know that. Then let us apply conditions of equilibrium. Sigma Fy equal to 0. When I apply sigma Fy equal to 0, I get minus kdc sin theta minus 1 equal to 0. I get kdc equal to minus 2.236 kilonewton, which is a compression force. Now let us apply sigma fx equal to 0. When I apply sigma fx equal to 0 for the free body diagram, I get minus kcb minus kdc cos theta equal to 0, or kcb equal to 2 kilonewton, a tensile force. Now you consider another joint. This is joint B. So at joint B, you apply sigma Fy equal to 0. When I apply sigma Fy equal to 0 to this joint, KBD will become 0, no other vertical forces. Now you go for sigma Fx equal to 0. I will get KCB minus KBA equal to 0, or KBA equal to KBA equal to 2 kilonewton, a tensile force. Now you consider joint D. At a joint D, there will be 3 member forces meeting. Actually 4 members will be meeting. One more member with the 0 force I have not shown here, that will be KBD or KDB. Now there is a member force KCD, which is a known value 2.236 kilonewton, and it can be resolved into two components, KCB cos theta and KCD sin theta. Then KAD can also be resolved into two, KAD sin theta and KAD cos theta. Again further KDE is there. KDE is also resolved into two components, cos theta and sin theta. Let us apply sigma Fy equal to 0 to this free body diagram. I will get here KCD sin theta minus KDE sin theta plus KAD sin theta equal to 0. Sin theta can be cancelled everywhere, giving you KCD minus KDE plus KAD equal to 0. KCD is a known value. When I substitute KCD, I get minus KDE plus KAD equal to 2.236 kilonewtons. Then sigma fx equal to 0. When I apply to this particular free body diagram, I get KCD cos theta minus KAD cos theta minus KDE cos theta equal to 0. So here cos theta can be cancelled everywhere, and I will get an equation called KDE plus KAD equal to 2.236 with a negative sign. Call this as equation 2, equation 1 and equation 2. There are two unknowns. Solve these equations using calculator. You will get KAD equal to 0, KDE equal to minus 2.236 kilonewton, a compressive force. Now you consider the last joint here. Consider joint E. In the joint E, I will consider KEA. The reaction I have neglected because I am not interested in finding out the reactions here. This is angle theta, so it can be resolved into two components. One is KDE cos theta, another one is KDE sin theta. So when I apply sigma Fy equal to 0, I will get KEA plus KDE sin 26.57 equal to 0, or KEA equal to 1 kilonewton. Now let us draw a table, very important table. So here totally you can have 7 components. One is a member, another one is a P, next one is K, the length L, area A, E in terms of kilonewton per meter square, and delta is equal to PKL divided by AE. Always remember, K and P should be in kilonewtons, length should be in meters, area should be in meter square, E should be in kilonewton per meter square. Or you can also substitute P in terms of Newton, K in terms of Newton, length in terms of millimeter, area in terms of millimeter square, E in terms of Newton per millimeter square, then delta will be in terms of millimeter. So all the members you list out, all the member forces you list out, all the member forces due to a unit load you list out, all the lengths you list out, then all the areas you write down, the E value you write down, and calculate delta equal to PKL divided by AE. For example, for the first member AB, the value of P is 80, so 80 into 2 into 3 divided by 1250 into 10 raised to minus 6 into 200 into 10 raised to 6 gives you 1.92 into 10 to the power minus 3 meter. Similarly, you calculate the deflection for all the members. Once you calculate the deflection of all the members, the last column you will get that. You sum this to get delta C equal to summation of PKL divided by AE. So this column, the last column, you add all the values, you get this summation PKL divided by AE. When I add all these values, I get a value equal to 7 into 10 power minus 3 meter, or 7 mm as the vertical deflection. We remember that the same value we got for the same problem by using method of total strain energy and also Castigliano's theorem. Thank you.